Hi everyone. Today I'm going to do a little extension on section 9495, basically looking at the word problems using sine, cosine, and tangent. So this first example here is showing you that you have a lamppost and we're trying to find out how tall it is. So we did something similar to this with similar triangles where and even congruent triangles so that you could find distances without actually having to measure them. This would be another look at it, so knowing an angle. We don't have similar triangles. We did the things with like the flagpole made a shadow and a person made a shadow, and then you can compare them. This is knowing an angle and a distance and finding another distance. So for right now, it says that you stand, so this would be you over here. You stand 40 inches from the base of the lamppost, so that's your 40 inches. You measure the angle of elevation. So the angle of elevation, this phrase here, is that angle that is the angle that is created from the ground up. So this would be the angle of elevation here. What we know in comparison to that angle is the adjacent side. We know that the lamppost would be perpendicular to the ground. So over here would be the hypotenuse, which that is not a side that we know, nor do we need to find it. And the side we're trying to find is the opposite. So the trig function that we would want to use needs to have opposite and adjacent, which is tangent. So we could set up an equation using the tan function. So that would be tan of the angle, which is tan of 70, equals opposite, which we don't know. So that's the h, over the adjacent, which is 40. To solve this equation, we would multiply both sides by 40. Whatever we do to one side, do to the other. And then this is just canceling out. So all we'd have to do is go to the calculator from here. So on the calculator, just clear out that last problem. So we were doing for this one, 40 times tan of 70. 40 times the tangent of 70. So about 109.9, which would be about 110 inches in this case. So about 110 if we rounded. To take a look at another example, this one, the picture I know is really small. Let's see if I can just make it, nope, making it bigger does not help. So we'll just work off of the picture here. It says you're measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation. So again, the angle of elevation is from the ground to the top of the tree. So for this one, we're going to find the height of the tree to the nearest foot. Again, you always want to look at the angle that you're given and decide the side that we want to find. How does that relate to it? So this is the opposite. This is adjacent because it's next to the side across from 90. This would be the hypotenuse, but we don't need that for this one. So you want to think about what uses opposite, adjacent, and then again, that is tangent. So for this guy, we would start with that information. We set up our equation. Tangent of 59 is opposite over adjacent, so we can substitute in. The opposite side was h, the adjacent side was 45. To solve that equation, we would multiply both sides by 45, put that into the calculator, and get about 74.9. This one does say to give the height to the nearest foot, so then you'd want to round it to be about 75 feet tall. So this is a way that you can use trig to find the heights of things that probably are not reasonable, sort of like the flagpole with the shadows. This would be another option if we need the angle measure, of course. To take a look at one last example, here we have a skiing person. So it says you are skiing on a mountain with an altitude. Remember, right before we left, I remember we talked a lot about the word altitude meaning height. The height is 1,200 feet, which means if your altitude is 1,200, you can really think about this value here would be the 1,200. If this side is 1,200, then so is this. So you'll see we kind of have two right triangles going on here, and you sort of have your option of what you want to work off of. What's different about this one is that they don't reference an angle of elevation, but an angle of depression, because this time the skier is going down. It's not going from the ground up to the top of a tree or a lamppost. We're taking what we call the horizon and then going down. So there's an angle of depression that's 21 degrees. Here, we're going to find the distance that you ski down the mountain, so the actual path that the person is traveling. So in this case, we're really going to work off of this right triangle. You could use you could use the other one, but since everything's labeled in this one, I'm going to use this. From this angle, the side we know is opposite. The side that we want to know is the hypotenuse because that's across from the 90-degree angle. So this time we need a trig function that uses opposite and hypotenuse, which is the sine function. So sine of the angle, sine of 21, would be opposite over hypotenuse. We substitute in that the opposite side is the 1200 and x is the hypotenuse. That's what we're trying to find. This would be the one where you have to multiply both sides by x and then divide out the sine of 21. So this, we would look like this: multiply each side by x, divide out the sine of 21, or you could do that shortcut where you're essentially just switching x and sine of 21. Do that on a calculator, and then in this case, again, round to the nearest foot, so 3,349 feet down the mountain. Hopefully these couple of examples were helpful so that you could see basically finding missing sides in a triangle. That's what we spent the end of last week doing, but with some real world situations.